The Singleton pattern restricts the initialization of a class to ensure that only one instance of the class can be created. I'm Balaji Chandrasekharan. Today, I will be discussing about the Singleton pattern and how to create a Singleton pattern in object-oriented language like Java. Please like and share my video, and subscribe to my channel. Singleton pattern is one of the gangs of 4 design patterns and comes in the Creational Design Pattern category. Singleton pattern restricts the instantiation of a class and ensures that only one instance of the class exists in the application instance. The Singleton class must provide a global access point to get the instance of the class. Singleton pattern is used for logging, drivers objects, caching, and thread pool. Singleton design pattern is also used in other design patterns like abstract factory, builder, prototype, facade patterns, etc. Singleton design pattern is used in core Java classes also, for example, java.lang.runtime, java.awt.desktop. To implement a Singleton pattern, we have different approaches, but all of them have the following common concepts. Private constructor to restrict instantiation of the class from other classes. Private static variable of the same class that is the only instance of the class. Public static method that returns the instance of the class. This is the global access point for the outer world to get the instance of the Singleton class. Now, we will learn different approaches to Singleton pattern implementation and design concerns with the implementation. In eager initialization, the instance of the Singleton class is created at the time of class loading. Here is the implementation of the static initialization Singleton class. I am creating a new class named eager initialized Singleton. I declared a new private static final variable instance of type eager initialized Singleton class, and initialized it with a new instance of this class. I created a private constructor to restrict instantiation of the class from other classes. Now creating a public static method that returns the instance of the class. This is the global access point for the outer world to get the instance of the Singleton class. Since the instance is created at the time of class loading, the JVM guarantees that the instance is created before any thread accesses the getInstance method, ensuring thread safety without explicit synchronization. Eager initialization is suitable when the Singleton class is lightweight and its instance is always required, ensuring simplicity and thread safety without additional overhead. The drawback to eager initialization is that the method is created even though the client application might not be using it. If your Singleton class is not using a lot of resources, this is the approach to use. But in most of the scenarios, Singleton classes are created for resources such as file system, database connections, etc. We should avoid the instantiation unless the client calls the getInstance method. Also, this method doesn't provide any options for exception handling. Static block initialization implementation is similar to eager initialization, except that instance of the class is created in the static block that provides the option for exception handling. The static block is executed when the class is loaded by the JVM. This allows for more complex instance creation logic and exception handling. The Singleton class has a private static final instance that is created within a static block. This ensures that the instance is created only once and is accessible globally. The static block allows handling exceptions that might occur during the creation of the Singleton instance, providing more control over the instance initialization process. The constructor of the Singleton class is private, preventing any other class from instantiating the Singleton class directly. The public static method getInstance returns the single instance of the Singleton class to the client. This method provides a global point of access to the instance. Thread safety is ensured since the instance is created when the class is loaded by the JVM. Both eager initialization and static block initialization create the instance even before it's being used, and that is not the best practice to use. The instance is created at class loading time, which may be undesirable in some scenarios where the instance is not always needed. Static block initialization is useful when you need to handle exceptions during instance creation or require a more flexible initialization process while ensuring thread safety and simplicity. Lazy initialization is a technique used to delay the creation of an object until it is needed. This approach helps in saving system resources and improving performance, especially when the object is resource-intensive to create or may not be used frequently. In the context of the Singleton pattern, lazy initialization ensures that the Singleton instance is created only when it is first requested. This can be achieved using different methods, each with its pros and cons regarding thread safety and performance. Lazy initialization method to implement the Singleton pattern creates the instance in the global access method. This approach is straightforward but not thread safe. If multiple threads access the getInstance method simultaneously, multiple instances of the Singleton may be created. Here is the sample code for creating the Singleton class with this approach. This is a static variable that holds the single instance of the Singleton class. Since it's static, it belongs to the class itself rather than any particular instance, ensuring that there's only one instance across the entire application. The constructor is private, which prevents any other class from instantiating the Singleton class directly. The getInstance static method provides a global point of access to the single instance of the Singleton class. The method first checks if the instance is null. If it is, it means that the Singleton has not been created yet, so it creates a new instance. Finally, the method returns the single instance of the Singleton class. The preceding implementation works fine in the case of the single-threaded environment, but when it comes to multi-threaded systems, it can cause issues if multiple threads are inside the if condition at the same time. It will destroy the Singleton pattern and both threads will get different instances of the Singleton class. To make it thread safe, you could use synchronization, double-check locking, or other techniques. A simple way to create a thread-safe Singleton class is to make the global access method synchronized so that only one thread can execute this method at a time. In this implementation, the getInstance method is synchronized, ensuring that only one thread can execute this method at a time. This prevents multiple threads from creating multiple instances of the Singleton class. The preceding implementation works fine and provides thread safety, but it reduces the performance because of the cost associated with the synchronized method, although we need it only for the first few threads that might create separate instances. To avoid this extra overhead every time, double-check locking principle is used. In this approach, the synchronized block is used inside the if condition with an additional check to ensure that only one instance of a Singleton class is created. Private static volatile instance ensures visibility of changes to instance across threads. The method first checks if instance is null without synchronization. If instance is null, it synchronizes on the class and checks again. If it is still null, it creates a new Singleton instance. This method ensures thread safety with better performance compared to synchronizing the entire getInstance method. Prior to Java 5, the Java memory model had a lot of issues, and the previous approaches used to fail in certain scenarios where too many threads tried to get the instance of the singleton class simultaneously. So Pugh came up with a different approach to create the singleton class using an inner static helper class. Here is an example of the Pugh singleton implementation. I am creating a static inner class that contains the instance of the singleton class. The instance object is declared as static and final, meaning it will be initialized only once and cannot be changed. The inner class is not loaded until the getInstance method is called, ensuring lazy initialization. This implementation is thread-safe, efficient, and lazy initialized. No synchronization overhead. It requires understanding of static inner classes. Notice the private inner static class that contains the instance of the singleton class. When the singleton class is loaded, singleton helper class is not loaded into memory, and only when someone calls the getInstance method, this class gets loaded and creates the singleton class instance. This is the most widely used approach for the singleton class as it doesn't require synchronization. Reflection can be used to destroy all the previous singleton implementation approaches. Here is an example class. I am creating a new class reflection singleton test. When you run the preceding test class, you will notice that hashcode of both instances is not the same, which destroys the singleton pattern. Reflection is very powerful and used in a lot of frameworks like Spring and Hibernate. To overcome this situation with reflection, Joshua Block suggests the use of enum to implement the singleton design pattern, as Java ensures that any enum value is instantiated only once in a Java program. Since Java enum values are globally accessible, so is the singleton. The drawback is that the enum type is somewhat inflexible. For example, it does not allow lazy initialization. Creating a enum singleton class. Adding a new constant instance and is globally accessible. Sometimes in distributed systems, we need to implement serializable interface in the singleton class so that we can store its state in the file system and retrieve it at a later point in time. Here is a singleton class that implements serializable interface also. The class implements serializable, enabling its instances to be serialized and deserialized. Serialization is the process of converting an object into a byte stream, and deserialization is the process of converting the byte stream back into an object. When a singleton class is serialized and then deserialized, the default behavior would create a new instance, breaking the singleton pattern. Instance object is serialized to a file named file1.ser using object output stream. The object is deserialized back from the file using object input stream into instance 2. The hash codes of instance and instance 2 are printed different means that two instances are created. It destroys the singleton pattern since two instances are created. To overcome this scenario, all we need to do is provide the implementation of readResolve method. After this, you will notice that hashcode of both instances is the same in the test program, means there is only one instance created. Singleton pattern is one of the simplest design patterns. This pattern involves a single class which is responsible to create an object while making sure that only single object gets created. We have reached the conclusion of this session and look forward to seeing you in our next one. We hope you have enjoyed the video. Don't forget to like, share, and subscribe. Thank you for tuning in.